Imagine the Earth's atmosphere, also known as the ionosphere, as a thick soap bubble. It is a membrane, a natural electrically charged shield around the Earth, protecting all life from deadly solar radiation.
We have to have the atmosphere for survival. I don't think we should do anything to damage it.
Without the ionosphere, I'd be fried, you'd be fried. All life on Earth would be fried.
In 1912, Nikola Tesla, a visionary genius, saw ways to tame the sky, to make the atmosphere glow. He developed alternating current, high-frequency radio technology, and free energy. He experimented with both high and low frequencies and electromagnetic waves. He envisioned altering the weather and creating shields around the Earth to protect us from missiles, and he claimed he knew how to split the Earth in two. In 1985, Bernard Eastlund applied for patents that could make some of these ideas real. Many claim that these patents have become the blueprint for HAARP, High Frequency Active Auroral Research Program.
ARCO originally approached me in 1984 to find a use for the natural gas on the north slope of Alaska, which they could not sell. To give you a feel for how much gas they asked me to find an application for, it was enough gas to produce all the electricity in the United States for a full year. I originated some ideas for military applications and beneficial civilian applications in which that gas would be converted into electricity and then used to power some gigantic antennas.
What does HAARP do? HAARP is a large antenna where we beam radio frequency energy up into the upper atmosphere, and we create on a small scale what the sun normally does. And the reason we're trying to do this is because when you have disturbances in the ionosphere, we can't communicate with our satellites.
HAARP began with a congressional insertion in the appropriations bill of fiscal year 1990. In essence, Congress directed the Defense Department to explore the potential for using the auroral regions for improving communications and navigation and surveillance. From there, the assignment came that the Navy and the Air Force were to manage the program. It is people from those two organizations that have worked together for the past 7 years.
Applications discussed in the patents included destroying missiles. Communications control and disruption were included. There were some other ideas both to possibly modify weather and finally to lift a portion of the upper atmosphere further out into space where hopefully it would be able to deflect missile trajectories.
What we do by beaming up radio frequency up into the ionosphere, that radio frequency, when it hits molecules of atmosphere, it tends to make the subatomic particles inside move faster, and that increases their temperature. So you can bring their temperature up to 1,600 degrees or so, which is normally what the sun does to those particles at that atmosphere.
The ionosphere of the Earth has got enormous amount of energy. There are 8,000 thunderstorms going on all over the Earth at any given moment. There are millions of amperes of electricity pouring to the Earth from lightning strikes, and HAARP could create a trigger effect.
In 1983, I did radio tomography with 30 watts, looking for oil in the ground. I found 26 oil wells over a 9-state area, and 100% of the time was accurate with just 30 watts of power beaming straight into solid rock. HAARP uses 1 billion watts beamed straight into the ionosphere for experiments. Picture these strings on the piano as layers of the Earth. Each one has its own frequency. What we used to do is beam radio waves into the ground, and it would vibrate any strings that were present in the ground. We might get a sound back like, and we'd say, that's natural gas. We might get a sound back like, and we'd say, that's crude oil. We were able to identify each frequency We accomplish this with just 30 watts of radio power. If you do this with 2 billion watts, the vibrations are so violent that the entire piano would shake. In fact, the whole house would shake. In fact, the vibrations could be so severe underground that could even cause an earthquake.
While we feel that HAARP is a unique facility, it's not the only one like it in the world. HAARP has some capabilities that we feel are better than some of the others. You can change the frequencies. You can shift the beam so that you can move it from one part of the ionosphere to another, and it has quite a bit more power than some of the other facilities throughout the world that are doing the same kinds of research.
I chose what's called a phased array antenna for the patents because it can be aimed. Picture holding your microwave oven in your hands with the door open. Then you can move it around and send those microwaves different directions. And for these applications where I wanted precise control of where the power was, I felt that was the best type of antenna to use. And that is the kind that HAARP has built.
What we can do with an antenna is change the portion of the sky into which we insert the energy.
HAARP can create some of the effects that the sun creates that are similar to the aurora borealis.
HAARP can paint designs in the sky, if you will. You know, it can take the beam and move it in any pattern that the scientist who's doing the experiment might want to do.
What I'm holding in my hands is an electrodeless lamp. In it, I have a low atmosphere gas, somewhat similar to the atmosphere above the Earth. I'm now going to put this in the microwave oven, which will irradiate it with about 1 watt per square centimeter.
You know, you put 1 watt out and you've got the fields necessary to break down the air, or whatever happens.
And you see all of the motion of the plasma. That's typical of what will happen at high altitude, where the ionosphere gets irradiated with these big beams.
That was 1 watt per centimeter. HAARP focuses 3.6 million watts and squeezes it into a billion-watt or gigawatt beam.
We're squeezing the megawatts into a narrow beam. Then in a very tiny area, you can create what's it called, an effective gigawatt.
Is HAARP safe? Yes, HAARP is safe.
The Earth is a web of interconnections. How do we know what we're doing when we blast the upper atmosphere with a huge amount of energy?
It takes a tiny, tiny amount of energy to release a huge amount of energy. It's the same as a bullet. For example, if you have the primer on the back of a bullet, and that primer releases a tiny amount of energy, but it triggers the larger power in the bullet itself. And HAARP is playing with the energy system of the Earth.
In the HAARP program, we have, I believe right now, 18 different colleges and universities that are working the program with us. University scientists are interested because they're studying science, and this is a major effect on the Earth, and so they want to know more about what it is and what it does.
HAARP has no effect on the Earth.
HAARP began in the 1980s, and we were just beginning to learn about chaos theory, how a tiny stimulus can change the dynamics of a living system like the human body or the whole living Earth. I don't think the people who developed HAARP were even aware of that science or its impact in the life sciences. Today, our knowledge is much bigger about how tiny effects can drastically shift the health or well-being of a living thing.
It is possible with a big beam to take a part of that upper atmosphere and push it out further.
What they're not paying any attention to is what's happening to the ionosphere while it's being held 80 miles out into space by this high-energy beam. It's heating up. And all of the molecules in that ionosphere region are absorbing energy out of that radio beam. And if they pick the right frequency to push that plume out into space, that energy may discharge back out of the ionosphere, back down the radio beam, and strike the Earth. And it would be about 100 times the energy released out of a thunderbolt. And that's how much energy would be released.
In certain applications, the military acknowledges that it can literally lift the ionosphere. And what they say is, it's not a problem, it's a short period of time, yet when you lift the ionosphere up, the lower atmosphere rushes in and fills that void, which changes localized weather patterns.
HAARP papers say that they intend to lift up a part of the ionosphere, which creates a hole, and they say that it heals over quickly. But what happens if you create enough holes that it just can't quite take care of it fast enough?
As far as creating a hole, to me, it's the analogy of you put your hand in water, and yeah, you're taking up space, but when you pull it out, it goes back together again. Same way the ionosphere would work.
If the hole means that the neutral density has been somewhat modified, then if you want to call that a hole, maybe that's fine.
The hole would be at least 30 miles long, half a mile deep, 50 to 60 miles above the Earth.
I imagine there are hundreds of satellites that have interactions with the ionosphere. They're all doing their own local modification of the ionosphere. They're all creating their own holes.
Satellites, rockets, space shuttle flights, not just HAARP, but many technologies out there in space are creating holes in heaven.
As to this question of injecting more high-energy particles into the Earth's electrical system, the ionosphere is a dynamic system, ever moving, ever changing. I don't think anyone on this planet really knows the point where enough is enough.
This was the planning document that really brought HAARP into being, and the absolute requirements ran from 1 gigawatt, which is 1 billion watts, all the way up to 10 billion watts of effective radiated power with a desired level of 100 billion watts.
At its biggest size suggested, if you beamed it for an hour and a half, that would equal the energy in a hydrogen bomb.
It's just a person's concept of what might possibly be done. Doesn't necessarily mean the government endorsed it or not.
What's the power when it pulses? And I can't find that in any of the documents that I've looked at. If you have a very small battery, you can put it in a small pen light and turn it on and have for some time a little bit of light. You can take the exactly same battery and put it in your camera, and when you flash that camera, the light will blind you. The nature of radar and these electromagnetic supplies is they can usually be pulsed. So one very good question for people to ask is, what is the peak power of that antenna when it pulses at its full capability?
Pulsing it doesn't matter.
To make it bigger, all they'd have to do is add additional elements. In fact, the request for proposal specified a design that could be added onto.
The first module is what's called a developmental prototype, and that's 48 antennas in a 6x8 array.
What you're looking at is the HAARP site in Alaska, or at least about 1/5 of the HAARP site. When this is completed, you'll see about 180 of these poles. Together, those 180 poles make up one single antenna, designed along with these cross members and a wire mesh here to send all the information, all the radio frequency energy that is generated by these trailers up into the ionosphere.
As they acknowledge in their papers when they say, we don't know what will happen when we push it to the next level of effects.
The military record explains it as phase 1 of a multi-phase project. It's going to get bigger, it's going to continue, and that's again why we're concerned.
There's always a limit to everything, although we don't know exactly where that limit is.
We are surrounded and bombarded by millions of megawatts of natural energy because the sun blows a solar wind which crashes towards the Earth. Since the Earth is a giant magnet, the magnetic field called the magnetosphere protects us. HAARP's original patents were designed to distort or alter the magnetosphere.
It's interesting to compare humans and the Earth. The Earth has a magnetic field. Humans actually generate a magnetic field too, especially in our hearts and brains. Every cell in our body has a powerful magnetic substance called magnetite, which responds sensitively to magnetic fields in our environment. if HAARP is altering the magnetosphere, which is the magnetic field of the Earth and all around it, surely this will have an effect on our health and on our physiology.
HAARP's combined antennae generate a focused billion-watt high-frequency radio beam, which penetrates the lower ionosphere and interacts with the currents of the auroral electrojet. During this modification, this pulsing beam stimulates the ionosphere, creating ELF waves which can move great distances through the lower atmosphere and penetrate into the Earth to find missile silos, underground tunnels, and communicate with hidden submarines.
There's a current flowing through here called the auroral electrojet. You deposit energy in there, you're changing the medium, okay, and you're changing the current, and you're generating ELF and VLF waves.
In simple terms, the electrojet is a river of electricity high above us. And a paper that I've read recently adds to the indications that they intend to cause it to dip down closer to the Earth so it can be tapped for a huge electrical power generating station, which is insanity because they don't know what they're dealing with. They're dealing with the planet's electrical system.
The electrojet affects global weather. Sometimes during a magnetic storm, for instance, it touches the Earth. It can knock out telephone cables and power grids.
What HAARP is capable of doing is to modify the electrojet. By modifying the electrojet, that current in the ionosphere, it has a capability of generating low-frequency waves.
What essentially the system does, it's different, is instead of the radio frequency energy dissipating as it goes up from the antenna array, it's actually focused. And the larger the antenna array, the higher they can focus the energy. And once they get the energy up into the ionosphere, depending on what they want to do, they can create a secondary frequency causing the ionosphere to vibrate, sending that signal back down to the Earth. And what that essentially does is allow them the ability to communicate at very high data rates with submarines, also allows for the possibility of Earth-penetrating tomography, or in the vernacular would be like X-raying the Earth or looking into the Earth several kilometers deep.
I heard one of the scientists point out they can make these ELF waves penetrate the Earth and get an image when that comes back. When I did this in '85, that kind of capability did not exist.
We, in fact, are doing experiments, or plan to do experiments, to see if we can detect tunnels underground.
There is a way of being able to use this type of technology to be able to look for